Let's solve the skiing problem step by step. A skier is accelerating down a 30-degree hill at 1.8 meters per second squared. We need to find two things. First, what is the vertical component of her acceleration? And second, how long will it take her to reach the bottom of the hill if she starts from rest and the elevation change is 325 meters? Let's start by drawing a diagram to help us visualize the problem. We have a slope at 30 degrees to the horizontal. Our skier is moving down the slope with an acceleration of 1.8 meters per second squared. This acceleration can be broken into two components, one parallel to the slope and one perpendicular to it. For part A, we need to find the vertical component of acceleration. We can use trigonometry to find this. The vertical component will be equal to the total acceleration times the sine of 30 degrees. So y equals 1.8 meters per second squared times sine of 30 degrees. Since sine of 30 degrees is 0.5, this gives us 0.9 meters per second squared. For part B, we need to find how long it takes the skier to reach the bottom. We know the total change in height is 325 meters, and we just found that the vertical acceleration is 0.9 meters per second squared. We can use the kinematic equation. Change in height equals initial velocity times time plus 1/2 times acceleration times time squared. Since the skier starts from rest, the initial velocity is 0. Let's solve this equation for time. First, multiply both sides by 2. Then divide both sides by 0.9. Finally, take the square root of both sides. This gives us approximately 26.87 seconds. So, to summarize, the vertical component of the skier's acceleration is 0.9 meters per second squared, and it will take approximately 26.87 seconds for the skier to reach the bottom of the hill.